Hey guys, welcome back to the video. In today's video, we will understand about recursion. Alright, so recursion. First of all, I would ask you one question. What does recursion do and how it is different than loops? Okay, there are two ways to iterate. If I have to talk about iteration, there are two ways. One is loops and one is recursion. Now, what are the difference between both of them? How they are different than each other? Okay, normally people would solve many questions in recursion. But what is the main difference that distinguish between these two particular concepts? That we will be understanding today. So, if you watch this video fully, you will be totally understanding all the formats. Okay, I'll be just focusing on concepts today. In the next second part, we will be looking at some problems that are very basic and classic questions on recursion. So pay attention. So first comes the difference between loop and recursion that you have to understand. The first difference is imagine you are running a loop from 1 to 10. That is 1, 2, 3, 4, 5 up to 10. Then what would happen? The loop would go in a linear way. Okay, it won't come back. It will just go from 1 to 10. That's it. Once it reaches to 10, that's it. The work is done. But this is in case of loops. But in case of recursion, what happens? Imagine you are starting from 1, you reach till 10. Recursion. So in case of recursion, what will happen is it will go from 1 to 10 and then again it will come back to 10 to 1. Whether you like it or whether you want it or don't want it, it will for sure come. That is the nature of recursion. So in simple words, recursion is like a karma. It will for sure comes. It will come back. If you are doing good, it will come back. If you are doing bad, it will come back, right? So again, a philosophical representation of recursion. All right. So this you need to understand. So imagine a scenario where I am here and I am sending one of my friend to go to a shop that is 10 kilometer. So it will go to the shop and then again it will return back. Okay. This particular concept of returning back, this is the main difference between recursion and loop. Alright, how does it works? Let us see. Okay, we'll look at different scenarios, head recursion, tail recursion, but we have to hardly around 4 to 5 ways are there in which you can use this recursion. Let us understand all the ways. Okay, so first way, let me start with the recursion. So in terms of definition, if I have to say, recursion is nothing but a function that calls itself. Function that calls itself. Okay, this is a simple definition for recursion. Now we have understood recursion, also we have understood how it works and difference between, that is, it comes back. All right, now let us see by printing a simple first way is, imagine you are starting from 1 to 10, you are going, and while going you are printing the numbers. Okay, this is the first scenario. What is the first scenario? While going you are printing 1, 2, 3, 4, 5 till 10, but while coming you are not doing anything. Okay, this is the first case. But before going into the first case, what we will understand is, we will understand the structure. What is the structure of the recursion? Structure. Let's first understand the structure. Before starting any of coding concepts, you have to know how to use it. Okay, what is the structure? The structure is very simple. If I talk about Python, then let's say def function, one function will be there. Below there will be base condition. So always remember, the base condition will come first. What do you understand by base condition? Base condition is nothing but a condition where it should stop. Wherever it should stop the recursion, that is a base condition. In my case, 1 to 10 it should stop, right? That is nothing but base condition. And again, remember that always there can be multiple base condition. It is not like only one base condition should be there. Base condition 1, base condition 2. It can be multiple base condition can be there. After that, at the here, it will be recursive call. Recursive call will be there. That is, in case this is function, you will call it again, and then from here again it will go back, and then until and unless the condition is satisfied here, it will keep going in cycle. That is the whole concept of recursion. Alright, so the simple fact that I like this particular concept so much that, you know, the whole AI thing, the whole AI concept has been introduced in some way or the other from recursion. Okay, how it learns from the mistake. Okay, imagine I'll give you a simple example. Imagine you are here and you have to go through all the ways. Imagine these are different ways in which you have to go through and look for a biscuit. Imagine I'm telling you go and buy a biscuit. So what you will do? First you will go this side and try to find a biscuit. So again, if it finds, then it will bring, that's it. If it does not find, it will go try all the ways, and then once it finds out, it will come back again in here. All right, so next time what it will do? Next time it will go directly here because it have learned. Okay, the whole concept of AI, what AI does, basically AI will remember and learn from its mistake. It will not do the same mistake again and again. All right, that is the, you know, where we use dynamic programming, where we used to remember things. So it is quite interesting how the concept of coding will relate to the AI, conceptual AI. Okay, so here it starts from this point. So I hope you have understood this structure. Remember this structure. This is very important structure in order to understand recursion. Now the first one, what is the first way? First way is while going, you are doing something. Okay, while going, while not returning, or after reaching it, you are not doing anything. So let's do a program for this. The first way is very simple. Def fun. I'll just write a function fun and I'm calling it. I'm calling a function and passing 1. Okay, here I'll be catching it parameter as x. After that, what I'll do, I'll give a base condition. What is the base condition? If x equal to 11, then you return. Means once you reach the 11, what you do? You return. If you don't reach 11, what you do? You print x, the number itself, and then what you do? You call the same function incrementing 1. So next time, first it will be printing 1, second time it will be 2, 3, 4, 5, 6, 7, 8, 9, 10. Then after that, once it reaches 11, then it should return back. After that, it will come back again and again. As I told you, it always comes back. Okay, so here if you see 11, once it reaches, it will return back. Now here it is a head recursion or tail recursion. It is a tail recursion. Why? Because it is the last point. After that, nothing is happening. That is the last point of recursion. Okay, after that, nothing is happening. So let's just do a print, and you can see here while going, it will print 1 to 10. Okay, this is the first way of recursion that you need to understand. 1 to 10. It is returning also, but you are not doing anything. Okay, that is the main point here. Now comes second way. In second way, what will be done? In second way, what you will be doing? While going 1 to 10, you won't be doing anything. But after reaching 10, 11, that is, while coming back, you will be printing 10, 9, 8, up to 1. Okay, while coming back, you have to print. Let us do this. How it is done? So first, see, while doing this, we were calling the first printing and then calling. So this time what we'll do, we will print this later. We'll print this later. So what will happen? Observe this 10 to 1. As I told you, it is returning back. So this time what we are doing, while returning, I am printing 1 by 1 rather than while going we were printing. Okay, so this is what head recursion, means recursion is happening in head. After that also some things are always happening. While returning back, it is happening. So imagine this. What is happening? This line is very interesting. First, you are calling fun of 1. While inside fun of 1, from fun of 1 directly you are calling fun of 2. Okay? But while this line is running, one more line is remaining, that is print x is remaining in this part. So that will be kept in the stack. That will be kept in the stack, print x. Okay? So again it is going for 2. For 2 also, print x will be remaining in the stack. So like this it will reach 10. Once it reaches 10, again it needs to come back. So this time 11, till 11 it will go, and then it will come back to 10, because 10 called 11, right? 10 called 11, so it will come back to 10, and then it will check the stack. What was the last stack? Last stack was 10. So it will print 10, 9, 8. As because these lines were remaining, right? These lines were remaining. That is the reason it will come back and it will print. Okay, this is the second way. I hope you have understood it. Next, third way. Third way, what we'll do, while going we'll be printing till 10, and then while coming also from 10 till 1 will print. So how will print this way? Very simple. I hope you have till by now you have should be able to do this. What we'll do, we'll just take this, we'll copy this and we'll paste it here. So basically while going also we are printing, while coming back also we are printing. So observe here 1 to 10 and 10 to 1. Okay, 1 to 10, 10 to 1. So this is the third scenario. I hope you have understood. Okay, just the placing of recursion. Before recursion you are doing something, after recursion you are doing something. Alright, that you need to understand. The fourth one. So now let me take an example. What we need to do is, fourth case is, while going you need to print. After reaching 10, you reach the shop. Let's say you reach the shop. In the shop you will be buying some biscuit, and then again while coming you are printing. So this is the scenario that you need to print. 1 to 10 biscuit and 10 to 1. Alright, so how do you print? 1 to 10 it was already printing, 10 to 1 it was already printing, but after reaching 11 what we'll do, we'll print, that is biscuit. Very important. Okay, now see, look at the answer. Answer will be 1 to 10, then after reaching the shop it will buy biscuit, and then 10 to 1. Okay, I hope you are understanding this scenario. So after reaching 11 it will print and then it will return. Okay, now I hope you are understanding till here. Fifth scenario is, understand this scenario. I will reach 10. I will reach 10. I will take the biscuit, but I will not print it here. I will pack that biscuit. Packing. I'll do the packing, and then I'll come back till 1, and then I will print the biscuit here. So basically I'm going to shop. I am buying the biscuit, returning it till the 1, and then printing it. Okay, this is the scenario, fifth case of how we need to print. So what we can do is, we are returning here. Okay, we are returning here, but if you have to return, you have to write return rather than printing. You can't print it here because you are not eating it that way, in that position. What you are doing, you are returning the biscuit so that it will be returned here. As you are returning, it will be returned in the last call. So what is the last call? You are calling it here. You are calling it here, last call, right? So as it will go back, you have to catch it. How to catch it? You catch it in one variable named as a. Okay. After catching it, you are printing it again. The same way you are printing it again. No, nothing changed. But at the end, what you do? You return that a. Whatever you have catched. So first, what you are doing? You are returning back the biscuit, and then you are printing, and then again, after printing, you are returning that biscuit again back to the last call. Alright, so this is how it works. Look at this scenario, 1 to 10, 10 to 1, and then as you are returning here, you need to print it, right? Print where? The main function. The main function where it all started. So this is where you need to print. So let's see, 1 to 10, 10 to 1 and biscuit. Okay, I hope you have understood these 5 scenarios. I'll again just repeat it. First, way is to, while going the shop, you are just printing 1 to 10. While returning, you are not doing anything. Even after reaching shop, you are not buying any biscuit. This is the first scenario. Second scenario is, while going, you are not doing anything. While coming, you are printing 10 to 1. Okay, after reaching shop, you are not doing anything. While returning, you are printing 10 to 1. Alright, this is second scenario. Third scenario, while going, you are printing 1 to 10. While coming, you are printing 10 to 1. But after reaching shop, you are not doing anything. This is third scenario. Fourth scenario, reaching to 10, printing 8 biscuit and then coming back printing. This is the fourth scenario. Fifth, 1 to 10, bought biscuit, did packing, came back while printing and then ate the biscuit. Okay, these are the 5 scenarios. So these 5 scenarios you have to think about where you can use, at what scenarios you can use. Okay, there are different types of recursion questions also. The pattern, I would say, not all patterns are similar because it is not linear in nature. It will be multi-dimensional in nature. Okay, recursion, again, for me it works like magic. For me it is simply magic. So it is one of my favorite topic. So here we have learned all the 5 ways. Next class we'll be solving around some examples we will solve in order to understand how exactly recursion works. Okay, I hope you have understood this. Thank you. Stay tuned and subscribe the channel. That's it.